Hey guys, Assalamualaikum dan salam sejahtera. Let's move on to the tutorial 1.4, and this tutorial is coming from Stephen J. Chapman book, which is Electric Machinery Fundamentals. Then it is from problem 1.7. Okay, let me read the questions first. A two-leg core is shown in the next figure. So this is the two-leg core that is mentioned in the question. The winding on the left leg of the core is N1, which has the 400 number of turns, and the winding on the right core, which is N2, has 300 turns. Okay, 400 turns on the left, 300 turns on the right. The coils are wounded in the direction shown in the figure. Okay, as shown in the figure, it is wounded in such a way to produce the flux, which is the plug will be moving from to the top, and then from left hand side of the core to the right hand side of the core, and then goes to the bottom, right? So what we want to find in this question is the flux that will be produced by current I for the left hand side core given at 0.5 ampere, and the I2 is 0.75 ampere. Also given the mu r, relative permeability, which is 1000, and it is constant. So we want to find the flux in this case. So I'll write down in my canvas here, right? I'll draw back the dimensions of the core, which is we have a core like this. Then the current is flowing from there. Also, there is another winding which is injected by the current I2. So this is current I2, this is current I1, and the flux will be flowing in that direction, right? And given also the number of turns of winding N1, which is 400, and the number of turns of winding N2, which is 300, and the dimension is given as in the question. And also there are some information also given, which is mu r is 1500, sorry, mu r is 1000, and it is constant. Also given in the questions is the current I1 is 0.5 ampere, current I2 is 0.75 ampere. Now we want to find the flux that is moving, flux in Weber that is moving inside the core, right? So firstly what we do is to find the total MMF. We find the total MMF, which is F dot. Total MMF is the sum of F1 and F2. So F1 refers to the MMF at the left hand side, which is from I1. Then MMF F2 is from I2. So from here, we have N1 I1 plus N2 I2. Then we know that N1 is 400. I1 is also given in the question, which is 0.5. Then N2 is 300 and I2 is 0.75. So total MMF is 200 plus 225, which is we get 425 ampere turns of MMF. Then we find the total reluctances. Total reluctances is given by this equation, which is L, which is the mean path, divided by mu R, mu naught, and then A. A is the cross-sectional area of the core. So we get 2.6. Why do we get 2.6? Okay. The mean path, why do we get 2.6? Actually, we sum up all of the path. 1.5, so 0.1, so 0.115, 0.5, 0.15, so on, right? So kita tambah semua. For example, 0.5 ini ada 4 bahagian. 0.15 ada 4 bahagian juga. Okay. So 2 lah. 2 tambah sekejap. Tambah 0.5 darab 4. 0.5, 0.5, 0.5, 0.5 darab 4. Okay. Sebelum tu saya nak calculate dulu dia punya mean path lah. L is kita ada 0.5 meter itu 4 bahagian. 50 cm sama dengan 0.5 meter. 0.5 meter ada 4 bahagian. Kita tambah dengan how about 0.15. 0.15 juga ada 4 bahagian. 1, 2, 3 dan 4. 0.15 ada 4 bahagian. So daripada sini 0.5 2 bahagian itu sama dengan 2. 0.15 ada 4 bahagian sama dengan 6 kan? 0.6. So total mean path is 2.6 meter. Okay. How about A, which is the cross-sectional area? How about A? The cross-sectional area, kita tahu lebar dia is 0.15 darab dengan dia punya depth. Depth juga adalah 15 cm. 0.0225 meter square. So itu adalah cross-sectional area and also the mean path. So what we do now is to compute the R total. So R total is L over mu R mu naught A. So L dengan A kita dah ada. So we have already got the L, which is 2.6, and A is 0.0225. Before that, mu R is also given, which is 1000. Mu naught 1.256. Okay, so that's it. Then calculate lah, din down. We got 92.92002 ampere turns per Weber. Okay, next, once we get the total reluctances, we can find the flux. Which is the question wants us to find the flux. F dot divided by R dot. So we have the total flux, total MMF, which is 425. So this is the total MMF, total reluctance, so finally we get 4.619 times 10 to the power of -3 ataupun 0.0046 bundarkan 2 lah Weber. So this is the answer of tutorial 1.4. So this is the answer tutorial 1.4. So thank you so much.